Welcome everyone to another Tech 90. Um, First of all, in case you've never joined us before, let you know what a Tech 90 is. Uh, Tech 90 is called Tech 90 because we try to keep it around 90 minutes. So throughout this broadcast, we are going to play some video and we're also going to do live Q&A. So first of all, let everybody know who's in the room today. So that would be me. My name is Greg Bruntz. I am the National Commercial Technical Support Specialist for commercial with GRE, and JD is also in the house.
Hello. Yeah, thanks, Greg. I am tech support technical service advisor and then lead trainer for the residential department.
He's better at advisor, just in case you wanted to know. No, not. Hey, if you can't poke a little fun, what's the point of doing all this, right?
That's
Anyway,
right.
so today we'll be talking about the top three error codes and quick fixes. If you haven't attended Tech 90 in the past, here's a rundown of what to expect. First, we'll run a clip from a recent training that covers how to troubleshoot an E6 error code using GRE single zone testing tool. I think you guys will really enjoy that. Kind of drives it home of why that tool can be very important use to you. Highly recommend that tool, even if you're working on a multi-zone unit. That tool will also work on single zone or multi-zone units. After that, we will come back and chat with you live and answer any questions up to that point. So don't forget about that ask the question button. Then we'll continue with another section training to cover most common questions on error codes on the E6, F0, and H5. Finally, we will finish up with another live Q&A. We encourage you to get into the conversation. As a reminder, if you have any questions or comments at the time during this broadcast, use the ask the question mark icon on the right of your screen and send them our way. We'll answer any relevant questions until we run out of time. Relevant is the key word. Let's keep it on topic. We have a lot in the past. I've had a lot of people asking questions specific to jobs, and a lot of times that just is entirely too time consuming to get into job specific questions. So let's try to keep it generic to the topic of discussion today. So, all right. So before we get started, why did we choose this topic, JD?
All right. So what we did, we chose I would say the three most common calls that come into tech support. We also did add just just three common questions, or more than three common questions, actually, just common questions that come to tech support as a little bonus to start off with before we get into the codes. But then we also just took the most common codes we get and kind of dove into those even a little deeper than the error code tool will get. So that way you guys get a step by step of what to do and how to navigate those codes.
So there's no secret there. The number one, and correct me if I'm wrong, JD, the number one tech call that comes into our tech support team is the E6 error code. We get
Yep.
that phone call far more than we do any others. And it's communication error, and it can be a little tricky to troubleshoot. The one thing I want to add into that is as we run the video, get ready to run the video here using the service tool, that kind of just makes things a little more simpler for you. We have other ways to troubleshoot it as well. If you don't have the service tool, we plan on covering that as well in this broadcast. But first and foremost, the information that we give you as far as the E6 troubleshooting and the FO and the H5 and the other air codes we're going to be talking about today is not really just what comes in the manual, right? This is how the training that we do on this is based off of the phone calls we've taken and what our tech support team has had to do to figure out these problems and be able to fix them. And that's how we built the error code troubleshooting tool that we have online. And that's how we handle the calls when they come in live. Am I right, JD?
Oh yeah, that's
Yes.
correct. And actually, when you do call in, it on our website again, if it's after hours on the weekend when we're not available, you use that error code tool, just punch in the error code, and it gives you a step-by-step guide of what to do. So it's like we're there, but we're not.
Right, because
Yeah.
if you call in and we go through it with you, we're literally going to do pretty much all those same steps that Airco troubleshooting tool is putting you through, because that's the necessary steps to be able to figure out what's wrong with the unit and why you're
Yeah.
getting E6 air code. Other than the fact, unless you have the service tool, the service tool will make things a lot more simple for you, as you will see in the video. So, JD, unless you got something else to add, we're gonna go. I think we go ahead and run this video.
Yeah, let's go ahead and run it.
All right, let's run it.
Hi, JD with GREE. Today we're going to be troubleshooting an E6 code. We're going to be using the GREE single zone testing tool. The part number is GREG T2A3AD. Say we have an E6, what we're going to do is use this tool and we're going to hook up to the outdoor unit and simulate the indoor and bring on the outdoor to see if the issue is in the outdoor. Or if it's not, then we're going to hook it up to the indoor unit and simulate the outdoor and bring on the indoor to see where the issue is. So let's go ahead and wire this in. So the power is off. We have 3 wires here. They are labeled for you 1, 2, and 3, just like your connections are labeled 1, 2, and 3. Hooking up 1 to 1, 2 to 2. And when we do this, we're going to disconnect number 2 that goes to the indoor head, because we're using this tool to simulate the indoor head. So that's why we're disconnecting number 2 coming from the indoor head. And just connecting number 2 from the service tool. And we're powering the indoor head still. Now we have the indoor head disconnected. We're going to bring on the outdoor unit. We're going to power it up. 4 different options on the test tool: data monitor, replace indoor unit to detect outdoor unit, and that's what we're going to use right now. So you hit next. We're replacing the indoor head. It has an E6. If you look up here, we have an E6. So we're replacing the indoor unit to detect outdoor unit. So you press OK. Press OK once more. It's making sure that we disconnected the communication to the indoor. So the condenser fan just came on. We are in cool mode. What we're doing is waiting for that compressor to come on. Once the outdoor unit fully comes on, we know the issue is not in the outdoor unit. Then we can disconnect this tool and connect to the indoor head and act as the outdoor unit and bring on the indoor head. All right, looks like the compressor just came on. We have compressor frequency. So now we're going to go ahead and disconnect power. Now we're going to disconnect the testing tool from outside. Reconnect the number 2 that we disconnected earlier. We verified that the outdoor unit does not have any issues causing the E6, so we're going to hook up to the indoor head. We're going to simulate the outdoor unit and bring on the indoor head. So what we're going to do first is lift this cover up. Did you know you'd have to take this cover off right here? Already took that cover off. Power is off. What we're going to do is disconnect number 2 from the outdoor unit here. Then we're going to hook up all 3 connections to the indoor. Again, they're labeled 1, 2, and 3, just like the outdoor. So you hook up 1 to 1, 2 to 2, and 3 to 3. All right, so now that we have that connected, we're going to turn on power to the unit. So we're going to go to option number 3, which is replace outdoor unit to detect indoor unit. We press OK. And press OK again. It's making sure that we disconnected the communication to the indoor unit, which we did. Detecting right now, so it says please wait. We're trying to do is see if that indoor unit will come on with this testing tool. And it looks like it did. We're in cool mode. The fan just came on. We're on medium speed and it's reading all the sensors. We do not have an issue with the indoor unit. So now that you guys know how to use the service tool to solve an E6 problem, with GREE, we're by your side.
All right. Hope you enjoyed that video. That kind of covers the service tool and how you use that service tool to pinpoint whether or not your E6 air code is generated off of a problem with the outdoor unit, a problem with the indoor unit, problem with the wire. I don't know if it was stated in that video, but as JD showed, he was able to run the outdoor unit in that video. He was able to run the indoor unit in that video using the service tool, which tells you the indoor unit's good, the outdoor unit's good. Then the only thing that could possibly be wrong with that system is the wire. So what we would normally recommend is before you go pulling a whole new wire or replacing it permanently in the wall or however it's routed, if you possibly can, just take a 14-4 stranded 600-volt wire and just run it through a window or on the ground or, you know, any safe way you can run it over and just hook it up temporarily and see if it solves your problem. If it solves the problem, then you know, okay, here we go. We got to figure out a way to pull the wire, you know, from the outdoor unit to that head. So, JD, anything you want to add there?
Yeah, just like Greg said, you know, we focus on the wire. Of course, make sure, you know, if we have a pump wired and the pump's wired correctly, we'll get into that later in the training as well of how to properly wire that pump and what to look for there, what wires to break and whatnot.
Yeah, so what the video doesn't cover, but I believe he is talking about the DC bus voltage and stuff in there, and we talk about that in more of the solving the E6 air code without using the tool. But let's say the problem wasn't in the outdoor unit. Well, okay, so now you got to dive deeper. Say we couldn't get that unit to run. We're getting E6 air code using the service tool. Now we got to do a deep dive into the outdoor unit because everybody wants to blame the main board right off the bat. Well, it's got to be a main board. Let me just order a new main board. So, and that's not, I don't want that to come across wrong in this video. We're not telling you if you hook that service tool up to the outdoor unit and you can't make it run, then just disconnect the tool and order a main board because that may not be your problem. You could have a bad fan motor. You could have a bad compressor. There's multiple other components within there that could actually be driving that E6. Because what happens with a inverter-driven system, okay, and you have an inverter drive board, which most of the mini splits, the inverter drive board and the main board is all built into one board. And if you have say a grounded fan motor or shorted fan motor, that can drop that DC bus that JD was talking about in there low enough that it actually causes the E6 air code. So then if you get into that machine and you got the service tool hooked up and you're looking at the DC bus voltage, you power it down, you disconnect the fan motor, power it back up, and that DC bus voltage comes right back up. I think you better break out your own meter and ohm out that motor because more than likely you got a bad motor there because it's dropping that DC bus voltage so much. So it's just another, you know, just wanted to make sure I pointed that out. So JD, in the next video you're doing when you're troubleshooting using E6 without the service tool, you talk more about that, correct?
Oh yeah, yep. We talk about, you know, ohming each component out if you don't have, you know, if our communication signal is low, what to check, or if it's zero, you know, what to check. So I kind of give all different avenues, and then of course I go through ohming all the components out, what to look for, and then also, you know, even if sometimes the ohms show good, you know, it could still drag down, you know, something that's not showing up. Let's say in the motor, for instance, that motor could be bad, but still ohm good. And then when it tries to power up, be something internal in that motor dragging it down. So then you do process of elimination, kind of like Greg was talking about.
Okay, so there was a few questions came in here. I'm going to roll through them real quick. So does the service tool work on all GREE branded mini splits?
So good question. So the single zone mini split tester only works on the single zone. But it will work on the multi-zone, but you have to hook it up to each individual head. And then there's a multi-zone that only works on the multi-zone. It actually plugs into the board rather than how we showed you for the single zone, how it wires, you know, into 1, 2, and 3. The multi-zone actually plugs into the board. So then
JD, if you don't mind, let me clarify that a little bit more. Okay. So you can use the single zone service tool on a multi-zone unit. And you
Correct.
can test the operation. You can test it for E6. You can test it for, you can also use it for data monitoring. Okay.
Yep.
But what JD was saying was you have multiple indoor units. So you have wiring for 1, 2, and 3 on A, B, C, depending on how many indoor units you have on that system. So whichever zone you're connecting your wiring to, you're only going to see the indoor unit information for that zone on the indoor. You will see all of the outdoor information. So it's still a
Correct.
great tool, even for troubleshooting problems with it. Like I said, you just got to remember, unlike the multi-zone service tool, you're only going to see data on the indoor unit you're connected to. You have to power down, move the wiring over, and be able to see the indoor unit on the next head and the next head and the next head. On multi-zone service tool, you can plug into the board and you can toggle through with the tool to each indoor unit and see the data without ever powering down or anything like that. The disadvantage to the multi-zone service tool is you can't use it for E6 troubleshooting. The single zone service tool will let you use it for E6 troubleshooting. In other words, you can't simulate the indoor unit or the outdoor unit with the multi-zone service tool like you can with the single zone service tool. I hope I
Right.
clarified that pretty well. So
Yeah, you did.
all right, so another question. Can you go into detail on what the service tool displays? Is this the same as a Daikin VRV service checker? So, JD, I'm not real familiar with a Daikin VRV service checker. I've never used one.
Yeah, me neither.
But I would have assumed it's just like any other mini split service tool. I mean, it's giving you, like if I'm connected to the outdoor unit on a single zone system, I can see my temperature, my outdoor ambient temperature. I can see my condenser coil temperature. I can see my compressor discharge temperature. I can see the DC bus voltage. I can see the compressor speed, fan speed of the outdoor unit, indoor coil temp, indoor ambient temp. I can see indoor fan speed. I can see not pressures because they don't have pressure transducers in these machines, but I can see the temperature of the outdoor condenser coil. I can convert that to pressure and get basically what my head pressure would be. Same with the indoor. I can see my indoor coil temperature, convert that to pressure with the pressure temperature chart, and know roughly what my suction pressure is if I'm running in cooling mode, right? Or vice versa for heating mode. So, anything you want to add to that, JD?
No, I think you covered that pretty well.
All right. That's
Let's
all
see.
the questions. So let's roll that video about the troubleshooting E6 without the service tool.
Hi, I'm JD. I'm technical service advisor here with GREE, and also I am lead trainer for the residential department. Today we're going to be going over the most common questions and the most common error codes that we see come into tech support, which should be E6, H5, and FO. So we'll go over a few common questions that we see come in to tech support. So let's go ahead and get started. Real good common question we get is, how to get these plugs unplugged. So if you look at these pictures here to the bottom right, there is a little container clip called a holder. You can use like a little flathead screwdriver, pop those out like a little thermostat screwdriver. So on the spade terminals, the two top pictures, those would be on your compressor. So what you want to do, you want to slide that rubber back, and then there's a little tab lock that you push with your thumb, and then you can unplug it. Don't try to, manhandle those. You will break, either a board or break the spade. So again, just, for the plugs, remove that little red clip. It may be a different color than red. Sometimes it's white, sometimes it's black. You just remove that clip, then you can use your thumb and press the release button on the plugs. And again, on the spades, just slide that rubber back and hit the tab lock. We do get this call a lot. My filter is missing. The filter is not missing. Most people are used to lifting that front cover and seeing the filter. On some of the new models, the filters are going to be on the top. So the filter is not missing. It's just in a different location. All right, so another common question is, how do we change from Celsius to Fahrenheit? So what we want to do is we want to turn the remote control to off, then press mode and down or mode and minus depending on which remote you have. As you can see, we have pictures of two different remotes. One has a down arrow and the other one has a minus. So depending on which one you have, it's going to be mode and down or mode and minus at the same time. If you have one of our controllers, it's going to be mode and down as well. You just hit those simultaneously and that will change it from Celsius to Fahrenheit. These do come from the factory set up for Celsius. So we just need to change them to Fahrenheit, and it's simple to do, just mode and down or mode and minus. We get this call often. My display is not working. I have contractors that replace multiple boards and they're like, we got defective boards going on. So there's a light button on your remote. If you can see on the picture of the remote here, we have the light button circled. Again, you just hit that light button that will bring on the display. They do have that as a feature on there, so you can turn off the light for people like me that like pure darkness to sleep, or you just don't want a light on in there. You hit the light button, it'll turn it off. So just hit the light button, turn it back on. Don't go replace a bunch of boards before you do that. All Gree remotes are universal. So, if you do lose a remote, you don't have to have the exact one. So you can use a different remote, just some features may be missing or not there that you need temporarily until you get the correct one. This call we get often too. So say your head is turning off randomly. A lot of people, think it's something going on, replace boards. Again, there is an on and off timer feature on this. That way you can set it for a certain time to shut off, set it for a certain time to come on, depending on how you have it set. So we have it circled here. So what I always tell people is there's a clock. To the right of the clock is the time. To the right of that, and the far right picture should be blank. That means no timer is set. So when I first started working on Gree, I had this mistake myself, because to the right of the middle picture here, to the right of the time and the clock, it says off. So I thought that meant the timer was off. What that actually means, there's an off timer set. If it says on, that means there's an on timer. If it says on/off, that means there's an on and off timer set. So all you have to do is hit the timer button, and then of course it'll go through on, off, on/off, or blank. So again, if it's blank, that means no timer is set. So of course, if your head's turning off for you think no reason, because you do have it off, that would be because you have an off timer set. So keep that in mind. What is the iFeel setting? Again, there is an iFeel button on the remote. If there is not an iFeel button, push mode and up together, and that will turn on iFeel. So when iFeel is on, a little emoji will pop up there. That means iFeel is turned on. What iFeel is the remote then becomes your sensor. So your remote is going to become, where it's sensing temperature from. So you can set it on the couch next to you, on the bed, on your nightstand next to you. Again, you want to make sure that the remote is pointed towards the head and keep it within a range. Typical range is 15 to 20 foot. I recommend doing this for ideal comfort. Again, because it's going to be next to you rather than if it's not on iFeel, the bottom right picture, that is your indoor ambient sensor that is going to be in the indoor head. That is what senses temperature if you're not using iFeel. So I'm going to say for optimal comfort, I would recommend using iFeel. We get this call often too, the unit's overshooting temperature. Again, you want to make sure that you seal the penetration through the wall. Most of the time, the penetration for your drain and line set is going right out here, or right behind where that sensor is on this slide here, bottom right. So if there's some air leakage, that is where you're going to throw that temperature sensor off, and that head's going to think, if it's 0 degrees out, it's going to be pulling, because that fan runs, the fan's going to be pulling in that cold air across that sensor if you're not using iFeel, and trick that head into thinking it's colder. So that head is going to continue to run and overshoot temperature. Same thing on a 100-degree day. In cooling, the fan always runs. So it's going to be sucking in that 100-degree air through that hole and throwing off the head, so the head will continue to run. So again, one way to see if that is the issue, you can put it in iFeel that we just went over, see if that resolves your issue. Again, you want to seal the penetration on the interior and exterior wall. So that way you don't have any air leakage from the wall itself and from outside. So there was a wiring change that they did on some of the newer units. So the picture on the left used to have separate power. You got 1 and 2 coming in, and then the other one in 1, 2, and 3. That was separate. That'd be going to your indoor heads. So picture on the right, as you can see, they combined it. So L1 and 2 actually coming on the bottom of N1 and L. That's why they have it labeled N and L, 1, 2, and 3. So 1, 2, and 3 goes to your indoor head, but L1 and L2 are actually go to the bottom there where I have those red arrows going to. So we get that calling often. The next slide is showing what a contractor did. As you can see, he tried running on the left of the picture, his main power coming into 1 and 3 at the top, not toward the bottom. And then of course he tried putting, this is a 2-zone unit. He tried putting 2 zones on one head. Of course, we had some codes. Again, like just picture shows here. On the right, 1, 2, and 3 goes to your indoor head, and then the L1 and L2 would be where your power comes into the unit. So now we're going to get into, again, 3 codes we're talking about today. It's E6, H5, and FO. So we're going to get into, those are the 3 most common codes we get into tech support. We're going to be getting into a step-by-step of what to do and what to check. So let's go ahead and dive into this. So E6, of course, is communication error. Couple tips to check, before even diving into it really deep. Obviously, the communication is generated by the outdoor unit. During the first 3 to 5 minutes of the delay, the outdoor unit is checking the EEVs first, and then looks for the condenser fan, and last looks for the compressor. The board is looking for resistance to ensure that they are there. If getting an E6 within the first 3 minutes, we should focus on the outdoor unit and start checking communication, which we'll get into showing you how to do that here shortly. If it takes longer than 3 minutes, then we may want to look externally from the outdoor, such as wiring, pumps, etc., which we'll get into all that. And if we have a code at one indoor on a multi-zone system, it's something to do with that separate head. If we have a multi-zone with a code on all, say, 3 heads, and it's a 3-zone system, then we know we probably have an outdoor issue. If we only have it on 1 head of the 3 zones, then we want to focus on that 1 head, the wiring to that head, or the pump. All right, so time to get started with the step-by-step procedure. First check, ideally we want to make sure that this is a matching system. If it's not a matching system, sometimes that could generate an E6. You can check the model numbers on each unit and get a compatibility chart found on our website at greecomfort.com. Also, you can use our compatibility tool found under resources at greecomfort.com. The link is provided below. That's something new we added not too long ago. So you can go to our website, greecomfort.com, under resources. You want to go to compatibility tool and enter in your outdoor model or indoor model, and it's going to give you all the options of the units that you can match up with, see if we have, if it's a compatibility issue or not. So that's always a good thing to start with, is make sure that we have a compatible unit before you get into wasting much of time going down a rabbit hole. Second check we want to do is, of course, make sure that we have, ideally you want color-coded wires. So, in this example, we used a red, white, and black. You want to make sure that, you use the same color goes to 1 inside and outside, same color goes to 2 inside and outside, and same color goes to 3 inside and outside, as you can see in our picture here. So again, make sure all your connections are tight, and make sure that 1 goes to 1, 2 to 2, and 3 to 3. And again, use color-coded wires so that way you don't get that messed up. Third check, we color-coded it properly. Also make sure we use the correct wire. Again, 14 4-stranded 600 volt rated wire is what we want to use. Solid wires will cause an E6. It may work for a while, but it will generate an E6 eventually. So I tell contractors they can work for 6 days, 6 months, 6 years, but eventually get that code, an E6, if you use solid wire. And then also you want to use 600 volt rated wire, because that does help protect the communication frequency. Again, this is a no-no call that we got from the field. Contractor tried using thermostat wire for his communication wire. You can imagine he did get an E6. It did work for some time. So you can see the dust on the unit. Somehow it did work, but he did get an E6 code. replace the wire. That did resolve the issue. The fourth check we want to do is make sure that we have a good ground. A good ground is crucial for communication as it uses the ground for communication. So I put some arrows there. So when checking this on a 230 volt unit, you check from 1 to ground and 3 to ground, you should have pretty close to the same reading. You shouldn't have more than a couple volt difference between 1 and ground and 3 and ground. On a 115 volt unit, between 1 and ground, you should have 0 volts. That ensures that you have a good neutral as well, and you have a good ground, because on a 115 volt unit, we have 1 leg of power, and that 1 leg of power goes to 3. On a 115 volt unit, 3 to ground, you should read your 115. 1 to ground should read 0. And the fifth check, the communication wire cannot be broken or spliced between the indoor and outdoor unit. So you want a solid run from inside to outside. No butt splices, no wire nuts, anything like that. It causes resistance. This is DC voltage, DC pulses. So with those connections, it will actually create some resistance and generate an E6 code. Again, it could be just like using the wrong wire. If you use solid wire, it could work at the very beginning of the install, just like having, breaks in your wires. Again, you just want to make sure no splices and use the correct wire. All right, a little note here I have. So if you're not sure if your wire has splices, sometimes from your inside to outside, as it could be in an attic or it could be hidden in a wall somewhere, and you think that might be your issue, you can always run a temporary wire through a window, through a door, and see if that, resolves your issue. Of course, if you run a temporary wire with no splices and the correct wire and it works, then obviously we know we have some splices in there, or maybe a mouse chewed a wire, or who knows what, but a good way of always checking is just run a temporary wire. So in this picture, these are calls that I've taken. I have people send in that have an E6 code and they can't figure out why. The picture on the right, of course, this contractor did not do the install, and we ended up finding a hidden box that you can see was full of moisture and full of wire nuts and splices. We found this by running a temporary wire, ran a temporary wire, it worked. And when he was removing the old wire, he ended up finding this and sent some pictures in. Picture on the left is just they were short on wire, so they thought they would just splice in and add just a little bit of extra wire. Of course, that generated an E6 as well. The sixth check here, was there a condensate pump installed? So if there was, we need to make sure that it was wired properly. Leg 3 is the only wire that can be broken, otherwise we can get an E6. So on this picture here, we have a wiring diagram of how to properly wire a mini pump. We can also send out, that's found on our website. In this picture here with the purple wire through the pump, we're breaking leg number 3 through the pump. That will shut down the unit without generating a code. Like I say, if you splice, break any other wire, we're going to get an E6 code. Obviously, we can't break leg number 2 at all. But leg number 1, the unit will beep when it shuts down if you break that leg. So we don't want the unit beeping. That would upset some homeowners. All right, so now that all these checks have been finished, we can start checking for communication. So let's get started. So first, we're going to check with our connected and all our wires connected to the unit. Obviously, you'll probably want to get something out to record these measurements. You would be taking several. From N1 to 2, we should be reading it's a pulsing, fluctuating voltage, 0 to 55 volts DC. Sometimes it can go a little higher than 55 volts. 55 volts is ideal communication. N1 to 3 should be 230 volts. 2 to 3 should be 230 volts. N1 to ground should be 115. 2 to ground should be 0 to 55 volts fluctuating. And 3 to ground should be 115 volts. To the right, we have a picture showing kind of where we're taking those readings from on your outdoor unit. Again, so this is a fluctuating voltage because we are connected and we are communicating. So it's going to be pulsing from inside to outside. So some meters, depending on your meter, have issues getting this pulsing voltage. So it does depend on what meter you have and your batteries. So be sure to check your batteries in your meter. So now let's go over 115 volt unit. So N1 to 2 should be 0 to 55 volts. Ideally, we're looking for the same readings here from 230 volt unit to 115. N1 to 3 should be 115 volts. N1 to ground should be 0 volts. 2 to ground should be 0 to 55 volts fluctuating. Again, we're pulsing, so we are communicating. And 3 to ground should be 115 volts. So now what we do, as you can see in the picture, we're going to turn off power. We're going to remove number 2. Number 2 is our communication wire. We're on the outdoor unit, removing the number 2 wire that goes to our indoor head. So we're isolating the outdoor unit now. We're going from 1 to 2 on DC volts. We should be somewhere between 56 to 56 volts. 55 volts DC is ideal communication. And you can also check 2 to ground. 2 to ground should be right about that 54 to 56 volts DC. Again, 55 is ideal. If you go to the indoor unit, of course, you have to connect number 2 on the outdoor unit and then go inside and then remove number 2 from the indoor unit. You can test that on the inside. You should have pretty close to the same readings. So that's another way we can actually test to see if there is splices or, something going on with the wire from inside to outside. That's by checking inside, removing number 2 with it connected outside. So we should have fairly close to the same reading we do outside. You may get a little resistance through that wire, but it should be pretty close. So now we get into a little bit more of the E6 troubleshooting here. We have 0 volts DC from 1 to 2. We need to check the fuse on the filter board or main board to see if there is no filter board. If the fuse is blown, then we need to ohm the DC components to see if there's anything shorted, which we'll get into all this here in a few slides. The reactor coil is not in all the units, but if shorted, we can get an E6 code. And if nothing is shorted, then we may have had a power surge or electrical storm that took out this fuse. More than likely, there is no surge protector in place to protect the system. So again, having a surge protector is very important. It's going to protect this main board or our filter board. Here's some of the troubleshooting of ohming the reactor coil. A lot of people say it looks like transformer. It's very similar. It does have, some copper coils on there. So the reactor is an added protection designed to absorb voltage spikes and filter electrical noise against the inverter. So as you can see, there is spade terminals on there. You can undo these spade terminals and you're going to ohm the reactor itself. Your reactor should be 1 ohm or less. If it reads OL, you have a bad reactor. Probably had a power surge, something like that caught, in this reactor, did its job and protected the rest of the board most likely. So if that's the case, place your reactor. You can also ohm this fuse. It's going to be on your filter board. So to the left here, we have a combined main board and filter board. It's all one piece. To the right is the filter circuit. To the bottom right, next to those 3 blocks is going to be your little white fuse. On the picture to the right, it's a unit that has 2 separate boards. There's a filter board on the right, and then the other main board is on the left in that picture. So as you can see towards the top of that filter board, there's a little white fuse. That is the fuse we'll be checking. Ideally, you want to check that fuse with power on. You should read 0 volts across that fuse with power on. If you read 230 or 115 volts, depending on the voltage of that unit, then we have an open fuse. If we do have an open fuse, we're going to have to replace that board. That fuse is not replaceable. That's why it is very important to have a surge protector. Surge protector is going to protect these fuses on this board. This is the E6 troubleshooting on a 115 volt unit. So I have a picture of these capacitors. They are separate capacitors compared to your 230 volt unit that creates your DC bus voltage, that also creates your communication voltage. They are separate. They can be tested. You would have to, again, have a meter that reads up to 2200 microfarads or a little higher. Again, that's how much these measure each. You can also, there's like on the picture here to the left, there's a little like rubber cap. So if the cap is missing, like, on the right side of that picture, the cap is missing, you just see a black little hole. That's kind of what it looks like when that does blow. That's not the only way to tell if it's good. I obviously want to, take the wires off and, use your meter and check the microfarads on there. And they should be somewhere right around 2200 microfarads. So if they're weak, that might be why you have a weak communication signal. All right, now let's go over the importance of the surge protector. So surge protectors are highly recommended just to protect every component on this inverter driven system, from your compressor to your condenser fan to your EEV. Anything that's controlled by DC voltage is highly susceptible to power surges. So that's why we want to have a good surge protector on there. Ideally, you want to have an adjustable surge protector. If you do not have an adjustable, it won't assist until 300 volts, like most surge protectors, which leaves the unit unprotected, as 253 volts is the max to a lot of our units. And also having an adjustable one, you can set it. I always recommend setting it for 190 and 252. Again, because, if it goes below the 187 volts, that's the lowest, that the unit can have for input voltage. That could cause damage to the components as well. So again, surge protector, an adjustable one is recommended. So if we have a low communication signal, we may have a DC component dragging down our communication. So first step we would want to do to, if we do have a low communication signal, say we have 38 volts DC, first step we want to turn power off, allow that board to discharge, take to about 10 minutes. Then we want to unplug the DC components, such as your condenser fan motor, your EEV, and compressor. Next, we want to turn on power, check communication to see if DC voltage is, somewhere between 53 to 57 volts DC. I'd actually, 54 to 56 is more ideal, but, 53 to 57 is, we're in that range. And then, we know, hey, we got something dragging down our communication, what is it? So lastly, we can ohm each component to ground. So we'll get into that here on the following slides. So this would be ohming the EEV. We have a good picture here. Gray is our common. When you're ohming the EEV windings themselves, you're going to go from gray to each color. They should be, in this example, 46 ohms. As long as they're close to each other, that's what we're looking for. Doesn't have to be perfect, but we're looking for somewhere around 46 ohms. But as long as they're all within a few ohms of each other, should be good. And then ohming it, each leg to ground should be OL, which if we have a reading between ground and any one of those colors, orange, red, yellow, black, or gray, then we have a grounded EEV. So, we can replace that. Which something else that could cause this EEV coil to ground would be some rust or corrosion. We really mostly see this on areas that are located next to bodies of water or bodies of, the ocean. Salt water causes corrosion. Greed did change the type of metal they were using a couple of years back, and I'm not seeing as much rust or corrosion on these. So that is, a good thing too that they did that. But so mostly on the older units, we'd be looking for some rust or corrosion that can cause them to short, or can even cause, them to not modulate properly. So something definitely to check on your inspections. So now we're ohming your condenser fan motor. This would be a 3-wire one, depending on your unit. Some have a 3-wire, some have a 5-wire condenser fan motor. The 3-wire you would ohm out just as kind of you would your compressor, which we'll get into in another slide. Looking at UV and W. So what we're doing is looking for equal ohm value between the 3 windings. So example, the different BTU models would have different readings, so don't always expect to see, if you check one unit, say an 18K unit, you could get 45 ohms between all your different windings. Then you can check a 36 BTU unit and you could be getting 65 ohms. So don't just think it's going to be the same every time you check one. As long as we're close to equal to between the 3 windings, that's what we're looking for. And of course, each leg to ground should be OL. So U to ground, V to ground, and W to ground. We're looking for an OL reading. If we get a reading between there, we're shorted. Then we want to replace that condenser fan motor. Ohming the 5-wire condenser fan motor, we're not looking for equal resistance. It's not just 3 legs. So what we're going to do is we're just going to ohm each leg to ground, looking for an OL reading. As long as we're getting an OL rating, that motor is not shorted. So now we get into ohming the compressor. You got UV and W, 3 legs. And as you can see in the picture there, we're just going to ohm each leg to each leg. So U to V, U to W, W to U. We should be reading about the same. We're looking for generally it's somewhere around 1 ohm between each leg. Typically we don't see it, if it's higher than 2 ohms, we would start looking into, we may have an issue with that compressor, or below 0.3 ohms. Again, ideal is right around 1 ohm. Again, you can always check your meter, touch your meter leads together, make sure that we're reading 0.0. So that way we know your meter leads are good and your battery is good. And before we even do these readings. So get into a little more here. So if we find the component is shorted or out of range, of course, we need to replace that component. If the components all check out, then we may need to use a process of elimination and plug one DC component in at a time to see which one is dragging down communication. So example, at power off already, board's discharge, we're going to plug in your EEV, turn power on, check your communication. If communication is 55 volts, then we know, okay, hey, it's not that, and then turn power off, wait 10 minutes for that to discharge, and then plug in your next component. Most of the time, you're not going to have to go through this because, ohms are, checking these out is going to figure out which one it is, but sometimes it's something internal that doesn't show up when we're trying to read ohms on those. Finally, if we have communication still getting E6, we most likely have an external issue. Being that we've already checked for splices, correct wire, correct wiring, up to 1, 2, and 3, the condensate pumps, then we may have a bad indoor board component or fuse on the main board. Could be open. So the indoor board, it's not on all of them, but a lot of these indoor boards do have a fuse that protects the rest of the components in there. This fuse does come out, so we can pop that, turn power off, pop that fuse out and ohm that fuse. So if that fuse is blown, it could have been a power surge and the power surge protected the rest of the components, or it could have been in one of the components in the board or in that unit that caused this to blow. So, then we can get into, as you can see here, if you have the fan motor that has 2 different separate plugs, you can, of course, unplug, and we're going to ohm the 3 windings there that's highlighted to PG. Ohm each of those to ground, make sure they're not grounded out. That reads OL. That motor's probably good. Then we have a stepper motor. Here are the ohm values for your stepper motor. Again, as you can see, we're just looking for, it doesn't have to be 390 exactly. What we're doing is looking for as long as we're close. So again, you're going to go from yellow to pink, yellow to blue, yellow to red, and orange to red. And as long as we're pretty close to equal resistance, then we have a good stepper motor. So if we have the 5-wire fan, again, we're just same as we did for your outdoor 5-wire fan. We are going to ohm that out, ohm each leg to ground, reads OL, then that fan motor is not shorted. Here's the power test for the 5-wire indoor and outdoor fan. So of course we're have the motor unplugged, have power on. From 1 to 2, we're looking for a 300 bus volts DC coming from the outdoor unit to your motor, or that would be on the outdoor unit. And the indoor unit, the 300 volts DC comes from the indoor board, comes from those capacitors on there. So from 2 to 3, we're looking for 15 volts DC. The picture to the right is 15 volts DC. That's what powers, tells the motor to speed up, slow down. It's kind of the power test, but more than likely we're just looking at ohms here, but I just figured I'd, give you guys the power test too. A little note here, if getting an E6 and it's looking like an indoor component and they ohm out, then we can unplug the components until E6 goes away and do process of elimination and replace the faulty part. Kind of like the same thing we did on the outdoor unit. Obviously we would check everything else first to make sure everything else ohms out. If nothing is showing shorted, but something's dragging down our communication, it could be something internal in that part that's not showing up on our meter, or it could be our meter. And then you can just do a process of elimination and plug in one component at a time to see which one is dragging down your communication. So don't forget about our air code tool. It can be found at greecomfort.com. You can go to the contractor dropdown and click on air code tool. In this example here, I entered E6, and it's going to give you kind of the step-by-step guide we went through today. But today I even went a little more in depth than our air code tool, just to give you a step-by-step guide. That way you guys knew every route to go. All right, so we're going to go ahead and take a break right there and answer some questions that have came in.
All right, welcome back, everyone. Hope you enjoyed that video that JD did about the E6 troubleshooting. So without further ado, let's jump right into some questions. What do you think, JD?
Yep, sounds good.
All right. So first question is from Mike. He wants to know, where do I pick up the testing tool?
It's a good question. So you want to contact your local distributor, and if they don't have it, they can order you one. We do have them in
And
stock.
to help with that, we can at least show you where to get the part numbers and stuff. So if you go onto greecomfort.com and you go under that contractor tab, and you'll scroll down, you'll see Gree Service Tools. You click on that, and if you scroll down from there, it gives you the service tools that we offer. You'll see the one that JD was using in the video. It's an old picture on that video of the service tool, and there's a reason for that. I'll explain to you why it shows the old one and not the new one. It's because the new one, if you've seen in the video from JD, there's a lot of glare. No matter how we try to get that picture, it just shows shadows of who's taking the picture. It's
Right.
You can't get a good photo of it. So
Yep.
we ended up using the older version because we get a decent photo of it. But the tool functions the same way. It's just a newer style service tool, just like JD used in the video. And then the multi-zone tester, again, like I said earlier, that one won't help you with E6 air communication troubleshooting. In other words, you can't simulate with it like you can with the single zone. And then we also have the Multi-Pro full system commissioning and service tool. And then we will be having a Flex R32 service tool coming soon. We still don't have that complete. It's not completed and ready to go just yet for us to start ordering those. So anyway, so now you know where to get them as well. So, all right. Another question was, they want to know if that service tool would work on the older mini splits. I can't see any reason why it wouldn't, because the
Right.
communication protocol that Gree uses on the mini splits is the same as it has been for quite some time.
Yep.
So, another question was, can you see the EV patient? Wow, man. Sometimes, you just get frogs in your finger, in your throat or your tongue or something. I don't know what causes it, but maybe it's old age. Maybe it's bald headedness. Who knows? Anyway, the question, does the service tool show the EV position on the outdoor unit? Keep in mind,
Yes.
on mini splits, the EV is located in the outdoor unit. Doesn't matter if it's single zone, multi-zone. If it's multi-zone, you're going to have an EEV for each indoor unit. If it's
Yep.
single zone, you're going to have the one EEV. Now, multi-pro, not to confuse that, multi-pro EEVs are located on the indoor units, not in the outdoor unit. There is EVs out there, but that is for refrigerant flow for heating mode. Same as when a mini split, though, they have one EEV, and it's going to cover your flow for cooling mode, and then the EEV is also going to cover your flow for heating mode. Okay.
Yep.
So anyway, but I do believe it does show you what position that EEV is in on the
Yep.
mini split service tool.
Yeah, it's up to like 480 steps, but it'll tell you what step it's actually in. You can
Yeah,
watch
so
it
the
open and close.
the EVs that Gree uses are from 0 to 480 steps.
Yep.
So let's see. So Andy asked, I'm not exactly sure, it's probably in the video. He wanted to know if the controller in the background, I'm not exactly sure what controller was shown in the background, because some of that's just background stuff, not exactly what we're talking about. Does it show room temperature? As far as I know, the only controllers that can show actual room temperature and not just the set point is the multi-pro controllers, and it's only certain ones, like the XE70 shows it, the XE7C, you can set it to show up room temperature. Anyway, not all of them will, and I don't believe the mini split wall controllers actually give you room temp,
Just
which
set point,
leads me into something else. So it's being worked on now. Just thought I'd pass this. I've said it multiple times in other videos. I'll say it again. We're fixing the GREE app. So if you are doing Wi-Fi, which most of the mini splits come with, Wi-Fi capable, right? Then once the app is revised, you will be able to see not only set point, but you also be able to see room temperature from the app. And you'll also be able to see if the unit's out on an air code. And then also you can set it up for email notification. So that's huge because we're becoming, unlike just mini splits, a lot of what we're offering now can be whole home systems, right? So if you're away on vacation or something like that, and you're leaving in the middle of winter or middle of summer or whatever, and you want to know if the temperature's getting out of control in your house, you can set up email notifications for a specified temperature. If it falls below or above that temperature, you get an email alert, whether you're doing it for cooling mode or heating mode, right? So there is some, but it's probably not going to be till the end of November or into December, maybe even be the first part of January before that whole revision's completed. So somebody else asked, can we get a copy of the training emailed to you? So this is a whole video training that we're doing. So this particular broadcast will be reposted on GreeComfort.com, and it'll also be shared on our YouTube channel. So you'll be able to access it for further use if you want to review it. All right, next question I got. Is the reactor coil unique feature to GREE? So he's talking about the reactor coil on the inverter drive boards. Cannot believe that would be unique to GREE, because I've seen multiple inverter boards. So what you got to think about, what is the function of the reactor coil? The reactor coil is there to mitigate noise back onto the power source. That's what it's for. Noise, when I say noise, I'm talking frequency. You'll get back EMF, you'll get frequency thrown back onto the power supply if you don't have that reactor coil to absorb that. That's what that reactor coil does. So if you didn't have a reactor coil on there, you'd have all kind of, let's call it poltergeist stuff going on in your home.
Right.
So, yeah, reactor coil is kind of important. So, and the other thing that you'll also see on mini splits, you'll see them on the multi-pro systems, you'll see them on commercial VRF, is them ring cores, where you'll see it just like a black donut, and you'll see wires wrap through it and then hook up to the board. That's the same thing. That's what that ring core is for, is to mitigate hertz noise and keep it from backing up on the power grid. Make sense?
Yep.
All right. So let's see if there's any other questions. Apologize for having to keep turning my head. I'm trying to look at multiple screens. So that was the last question.
Yeah.
Well, JD, I guess you did a really good job explaining E6 troubleshooting. Otherwise, we'd have a whole lot more questions.
That was my goal, to be where there's no questions and we know exactly what to do. So
we've got a quick minute to talk about it. What do you think is probably the number one cause to E6 air codes?
For me, what I see, I mean, of course, I would say probably install air if it's a new install. Not using the correct wire pump, not wiring the pump correctly, something of that aspect. Now, if it's after install, I would say the biggest thing that caused those is, like I say, not having a surge protector, and it blows that fuse on the board or damages a component. So that's why I do stress in that video how important it is, and also to have an adjustable one so we can set the over under to protect that unit both ways. So
I have to agree with you, but I also think one of the biggest things that we've seen a lot of anyway is splices. You really don't want to be splicing those wires, guys. You may get away with it, but for how long? The other thing is I've seen too, and you can probably attest to this too, JD, is using the wrong voltage rated wire, using only a
Yep.
300 volt wire instead of 600 volt. That 600 volt rating to that 14.4 wire is huge because it's the voltage rating of each individual wire in that bundle. And if you don't have a high enough voltage rating to it, you can get voltage bleed from one wire to the other. And since that one of those is going to be your number two wire and is your communication, if you're getting that voltage bleed over, that's what ruins your communication.
Yep.
So the other thing I can tell you in stranded, solid core doesn't work real well. And the reason why I say that is because of this. Guys have asked me before, why you guys recommend stranded wire? Why stranded? So, and then my question back to them is, all right, go out to your service van and tell me how many of your extension cords in your van are solid core. None of them.
Yeah.
Why? Because solid core wire is not flexible. Extension cords are used in stranded wire because it's flexible. And when you're pulling that wire through the walls and all that, you need that flexibility to that cable for them bends and stuff. So we're not pinching internally in that four conductor cable. Those wires inside that cable are not getting pinched to each other, because if they're getting pinched to each other, you're sacrificing some of that 600 volt rating to the wire, and you'll get voltage bleed from one wire to another wire, causing your E6 communication error code. So with that said, even though you're using stranded wire, you still need to run that cable neatly and don't be making real sharp bends with it and pinching it, pulling it, scraping it on things, stuff like that. You need to run that wire nicely, neatly, and make nice radius bends and stuff to the wire so that you're not pinching that cable funny, because that will also cause you E6 communication error codes.
Yep.
So all right. Well, I'm gonna look one more time for any more questions. JD, you got anything to add?
No, I think you're good there. I did have a whole slide on, why to use the correct wire. So it's good you covered it, but I went kind of in depth into exactly what you said about, using the correct rated wire and why. So you can't stress that enough. That's one of the biggest causes. Like I say, if you don't, you can do it at install. And I even said this in the training, it can be 6 months, 6 days, 6 years, but you're going to get that code eventually. And it'll probably be on a weekend or weeknight, and you have to go on an emergency call, and it'll be because the wire you didn't run properly.
Well, and the specifications are there to minimize problems, so you don't have
Right.
problems with the equipment. It's not like
Exactly.
it's not that we don't want you to be able to buy a cheaper wire. The wire isn't cheaper if you got to go back and redo it,
Right.
right?
Oh yeah.
So, the specifications are there for a reason, to minimize callbacks and have to go back and mess with that equipment.
Exactly.
So, all right. Well, I think we should move on and roll the next video on. We're doing FO next, right?
Yep. FO code is next.
All right, let's do FO and we'll come back and answer some more questions.
So now we're going to get into our second code, which is FO. FO is refrigerant protection lockout. What I tell people, this is probably my most common call. If you're getting an FO code, it's a hard reset code. Before you do the hard reset and turn it back on, you want to make sure, obviously, we have refrigerant in there, because that'd be bad to start the unit up without refrigerant. So that's why step one here, put gauges on, check standing pressure, and you want to compare that to your PT chart. They should be somewhere close. Step two, if they are close, then we need to do a hard reset. Again, this is a lockout code, so it's going to take about 10 minutes to do a hard reset. That's 10 minutes of power off. Step three, after the hard reset, see if the unit comes on in cooling mode or generates another FO code. This code is generated by the indoor coil sensor, as shown in this picture in the upper right. So you can see it's a little black wire going to, there's a little metal clip holding it in. That is where your indoor coil sensor is located. We can own this out. We'll get into that here coming up. The unit does not reset, then we need to be looking at the indoor coil sensor. The indoor coil sensor would more than likely be open, and that would prevent the code from resetting. If the unit does reset and comes on, then we need to see what our pressures are and kind of go from there. Here is, which you can find our ohms chart on our website, greekcomfort.com. Checking the indoor coil sensor. This coil is a 20K thermistor. GREE uses a negative coefficient thermistor rated at 77 degrees. So negative coefficient means temperature up, resistance down. If OL are out of range, replace the sensor and FO code should go away. To the right here is just a chart, and that's a chart you're going to find on our website. It's going to give you the 15K, 20K, and 50K. Those are going to be all the sensors that GREE uses. Typically, your 15K is your indoor outdoor ambient sensor. Your 20K is your coil sensor, your EEV sensors. The 50K is going to be your compressor discharge sensor. So again, on our website, you can find that, and you can be able to ohm out all the sensors that would be found in your indoor or outdoor unit. So if the unit is low or out of refrigerant, when you hook up your gauges, a couple things we want to do. System seems low by standing pressure, then power it up after the hard reset and check pressures to confirm. Check your running pressure. Typical running pressure somewhere between 120 and 150, but that's depending on load conditions, indoor, outdoor, ambient. And again, you want to let that thing run for a good 10, 15 minutes before jumping the gun, because that pressure will adjust and fluctuate. And it also depends on set point. If that unit is set for 4 degrees or more than the indoor temperature, the unit is going to ramp up to higher to achieve set point. So it all depends on set point, load conditions, indoor and outdoor temperatures to your running pressure. If the unit is low, then we need to search for a leak. Ideally, you want to start with the flares. That's where most of the leaks are. If the unit is out of refrigerant, do not power the unit up. And then we need to do a leak search. Again, we want to start with checking flares. Of course, it's recommended to use a torque wrench when doing the installs to prevent these leaks from happening. Again, most contractors that call in that have leaks are not using those. So again, use a flare gauge to make the proper flare. Use a torque wrench to make sure that it's torqued properly. All right, so once the leak is located, obviously we want to make that repair. If the leak is on the flare connection, use a torque wrench, which I did kind of say that earlier, to prevent that issue from happening again. And then we also advise doing a triple evacuation down to 250 microns. So again, if your unit does leak, we have an issue. We could have non-condensables in there, moisture. So again, that's why we want to do a triple evacuation to make sure to get any non-condensables and moisture out of there. Final step, we'd want to measure the line set and weigh in proper charge. A couple things here. If we get an FO code and it's not low on refrigerant or not a bad indoor coil sensor, we could possibly have a line set or strainer restriction, or we could have an expansion valve or sensors that control the expansion valve issue. I have arrows pointing to those sensors. This example here is just a little snippet of one of our diagrams. This example, tube A. Tube A has a liquid pipe sensor and a gas pipe sensor. That's what controls your EEV and allows that EEV to open. There are these sensors and it talks to the board. So one of these sensors is out of range. It could cause it to close down when it doesn't need to, and sometimes can result in an FO code or other codes as well, but just another possibility. So there is a strainer that is before and after each EEV. On the picture on the bottom right, shows you kind of what the strainer looks like. Again, when checking the strainer, you don't want to check with the unit running, temperature across on each side of the strainer where the arrows are, that temperature should be the same. If we have a difference in temperature from one side of that strainer to the other, that screen in there is restricted. So we have something in there. As you can see in the picture on the left, this is a picture that we got from the job site. Cut the strainers open. Somebody was pulling Armaflex over the line set, did not have plugs in the line set, and it was shaving off part of the insulation. And the insulation then was inside the piping and eventually made its way all the way to the strainer and blocked up the strainers. So again, be careful when you're sliding insulation over your pipe. Again, because there's not a filter dryer in here per se, as it does not have the moisture balls in there, but it does have the mesh screen in there that will collect and protect anything from getting into your EEV. checked out the strainer, it's not the strainer. Checked out your EEV, it's not your EEV or the sensors. You may have a restriction in the line set that's causing your FO code. So then we need to do a 4-point temperature check. It's best to have 2 temperature probes to do this test. Following slides will give you some detailed instructions on how to do that. So this is how to properly do a 4-point check. In this example, we have 4 zones, A, B, C, D. So what you would want to do ideally is have 4 temperature probes where you can just do 1 line at a time. So if you have 2 temperature probes, we'd want to, and I'm just going to use this bottom one as an example where these arrows are here. You want to have on your suction line on tube A, inside and outside, have a temperature probe. Let that unit run for a good 10 minutes. There should be very little to no difference from inside to outside. Again, anything more than 4 degrees, we definitely have a restriction in there. The shorter the line set, it'd be less than 4 degrees. So I tell people if you have a 15, 20 foot line set and you have 4 degree, we still may have a slight restriction. Again, it's on it's just on a longer one, but on a shorter one, you should have even less difference, like 2 degree difference from inside to outside on the shorter ones. So something else to consider when doing this, if you're checking a high wall head, you'd want to take off that front cover and you're going to check your temperatures entering and leaving the coil. So you're going to check entering and leaving the coil and entering and leaving the outdoor unit and check for a temperature difference. The reason why is because especially looking at the indoor head, if you went out the right side, facing the back of the unit, it's on the left side where that line set is. So a lot of contractors bend that line set out. A lot of times when they bend that out, they do kink that line. So we want to, again, be careful when bending that. GREE did recently add like a corrugation on there to help prevent that from kinking when bending that. Just, you want to be careful in doing that, but they did help put something in there to prevent that from happening. But that's the reason why we want to check from here and not on the outside of the wall, because we'd be missing that bend there. Sometimes it gets kinked. So again, don't forget to use our air code troubleshooting tool. It has most of these steps in there. I did add some, but again, greecomfort.com, the contractor dropdown. This example, I entered the FO code, and it's going to give you a step-by-step guide of what to do. All right, we're going to take a break here and answer some questions for you guys.
All right, we're back. I hope you enjoyed that, what JD did there about the FO code. It's not a hard code. We seem to get a lot of phone calls on it. I think part of the phone calls are driven from technicians out in the field Googling the FO air code. And I strongly encourage you not to do that for GREE products because you'll get a lot of the wrong information.
Right.
So if you need air code information, please go to greecomfort.com and go under the contractor tab and you'll see the air code troubleshooting tool. Use that tool and get on our website. Use that tool, punch in your air code, and it'll give you better answers to what the air codes actually mean. Anyway, JD, you got anything you want to elaborate about the FO air code? The no questions have come in. I just checked.
No, I just looked too. The main thing I can't stress enough is when you're doing the install, to use a torque wrench, use a flare gauge. That's the biggest reason we have an FO code, is because just not doing the flares properly. Sure, we have coil leaks just like any other manufacturer, but the main call I get is just leaks in the flares.
I guess the other thing too, JD, I don't know if you stress it or not, but we also want to make sure they're using the flare nuts to come with the equipment, not
good
the
call.
flare nuts on the line sets. Because the line set, when you buy line sets with flares already made on them and their own flare nuts, we highly recommend you cut them off and use the flare nuts and reflare and use the flare nuts that come with the machine. If you take your flare gauge or you inspect that flare very well, I've seen many of pre-manufactured line sets where that flare was improperly made because it's done by a mass processing flaring machine or something like that. So,
or even in transit, sometimes they get smashed or oblonged or something like that, and then you know.
And then the other thing I'll tell you is the flare gauge is huge, guys. It made a believer out of me. What really made it a believer out of me is when I was using the Navac power flaring tool, which I love the tool. But when you set up that thing to flare at like 1/4 inch, and then your next flare is like 5/8, without tool adjustment, you were going to make that flare wrong because there's no way the tool can be preset for both flares. So, and I don't use it enough to, you know, doing installs every day to set up the tool, but I know what I would do with that tool. I would figure out where I get my right setting for making like a 1/4 inch flare, and then I would set it for 5/8, and then I would make sure I got the right setting from there, and I would actually find a way to mark that tool for the adjustment screw so I knew exactly where to turn it for each one so that I could go from a smaller size flare to a larger size flare without having to keep adjusting the tool and keep practicing my flares, right? But Daniel and I, about a year ago or so, we did an install. We used that tool, and we found out real quick that that flaring tool, you know, had some significant adjustments from going from a small size to a large size. And we, you know, we used the flare gauge and it proved our point, right? So if you haven't used the flare gauge before, I highly encourage you to use one. They're really simple to use. All you do is hold it up to the right size flare hole. If the pipe pushes all the way through it with your flare, the flare is too small. If the pipe won't go in the flare hole at all, it's too big. It should go in, and there's a stop right in the middle of that gauge, and it should hit that stop and not be able to push through. Now you know you made the flare correctly. And I highly encourage you. Don't take, you know, you can have that thing in your back pocket, do your flare, whip that thing out, make sure it made your flare right, and you're good to go. So, anyway, teach their own for their tool. I don't care if you're using a hand flaring tool. You still want to make sure you're checking your flares with a flare gauge. Now, some of the better flare blocks that I've seen actually have that stop. And if you have a flare gauge, if your flaring tool that doesn't have that stop, so when you shove the pipe into the flare block, you have that metal piece there that doesn't let you push the pipe too far. It sets the depth of the pipe so you flare it right. If you have an older flaring block and it doesn't have that, then I would recommend you get a new flaring tool so that you have that stop in it, because that will help save you a whole bunch of time on the job.
Oh yeah.
But I agree with JD too, with the torque wrench as well. Because what you think is tight may not be tight enough. And what you also think is tight enough is way too tight. And you don't want to over tighten the nut either, because now you're smashing that flare. It's a brass to brass connection. And smashing that flare up in there makes that flare joint weak as well, because you've just weakened that whole part of the copper right there. But in other words, what I'm saying is you got a better chance of that breaking the pipe at the flare because you over torqued it. So
Exactly.
the torque specifications are in the installation instructions for a reason. And I highly recommend you use them. So anyway, JD, anything else?
No, I think we pretty well. I mean, like I said, I pretty well covered it in the training, but you know, we definitely added a little more there. So that was some good valid points.
All right. Well, I think we move on into H5. And like I said, guys, don't forget about that ask a question button on the right-hand screen. We do these videos for you guys so that you can get all the support we can possibly give you. So if you have any questions, throw them at us. We'll do our best to answer them. So with that, let's roll the video.
All right. So now we're going to get into our last code. It's an H5 code, which H5 is IPM module protection and overcurrent protection. First, we need to shut off power and do an evaluation and check out a few things. So this, again, is a hard reset code. So 10 minutes of off time. A couple checks we want to do. Of course, make sure that the filters are clean, coils are clean. Definitely generate an E6 code. So you can see in the picture on the right, that unit is caked. Clean that up. It could be what's causing your issue. Zoom in on those. Another thing to think about when doing this, most time this would be in a new install, but I do get this call often where getting an H5 code. Maybe they didn't open the valves all the way, or they didn't even open the liquid valve because the only valve that has a gauge port on there is your suction. So we get contractors that only open the suction one because that's the one that has the gauge port. But it's something else to consider and remember too, and make sure to open those valves all the way before moving to the next head or next zone. We also want to make sure that the system is properly evacuated, as non-condensables can cause an H5. So we want to make sure we have a good vacuum pump with new oil. I had a coworker who would only change his oil when it spilled all over the back of his van. So that's how I knew he got some new oil in his pump. So again, this should be done after every install. That is highly recommended after each install to put new oil in there. At least do it weekly. Just don't be my coworker that did it, every few months when it spilled all over his van. So anytime you do use a vacuum pump at new install, you want to make sure to pull your system down to 500 microns for a new install. If making a leak repair, or you want to do a triple evacuation to a minimum of 300 microns, it's always advised for a triple evacuation at 250, but minimum is 300 to do triple evacuation. Another thing you want to do is make sure if it's a multi-zone that the pipes and wirings are going to the correct zone. This could cause an H5. It's advised that install to label piping and wiring so we don't get them crossed up. So again, zone A, zone B, you can, just put some tape on there, label them so we don't get the wirings or piping mixed up. Because if you do have them crossed up, what we could do is, you make that mistake, just move the wires. You don't have to move the piping. Say if we get zone A mixed up with zone B, you can just move zone A's wiring to zone B and zone B's to zone A. You want to remove 1, 2, and 3 from zone A to B and then B to A. And you don't have to move the piping. But again, if you just label your piping and take your time and wiring when you're doing the install A and B and C and so on, you shouldn't have this issue. But we get that call often as well. Another thing to consider is make sure if it's a multi-zone that the pipes are the correct size. I mean, you could even do it with a single zone, but you would have to have adapters. But on a multi-zone, something to remember is they are sized according to whatever the indoor unit calls for, and the adapter would go on the outdoor unit, and you would increase the line size all the way to the indoor head. And if you're unsure where line size to use, you can go to our website, go to the submittal, in our website, greatcomfort.com, go to the submittal. In the picture on the right is the submittal. In this example, it's a 4LIV09. Again, there's a refrigerant piping section, and I zoomed in on it, and over here to the left, where that arrow is, it tells you the exact line set size you should use. In this example, it'd be 1/4 and 3/8. So 1/4 and 3/8, that is what's required from outside to inside. Couple other things, we want to make sure that the unit is properly charged and requirements followed. Again, you want to measure that line set, measure each line set on a multi-zone. Things to consider, what's the charge weight in? If you don't know, if you didn't do the install, you may want to pull that charge and weigh it in after measuring the line set. Another thing to make sure of is make sure that we are above the minimum of 10 foot, and make sure that we are not over the maximum piping allowed. Make sure we're not above the maximum piping to one head. Also make sure that we are not above the maximum elevation and lift to any indoor unit. The proper charge along with additional charge amount can be found in the submittal as well. Zoomed in on it for you and drew an arrow over to where it can be found. It's going to be found in the refrigerant piping data section. It's going to give you refrigerant type, refrigerant charge, the amount charged per additional line length. In this example, it is 0.21. That's ounces per foot. So you measure your total piping and anything beyond. Let's see, factory charge for total length is, so this unit's factory charge for 98 foot. So anything beyond 98 foot, you'd add the 0.21. The total refrigerant pipe length, the maximum for this whole system, would be 197 foot. Again, this is just an example of a unit. That's not every single unit. Every single unit would have different piping requirements. It gives max elevation, max lift, max drop. Again, you just want to be sure that all those are followed. If they weren't followed, that can generate an H5. So if everything checks out and still getting an H5, then we may need to ohm the compressor out, which we went over that in the previous slides, but we can go over it again. Again, you have U, V, and W. You're just ohming each leg to each leg. This should be somewhere right around 1 ohm, typically no higher than 2 ohms and no less than 0.3. If we're out of those ranges, then we have something going on with that compressor. And again, right around 1 ohm, and of course OL to ground. So U, V, and W to ground should be OL. Another thing to look at would be has the board been replaced? If the board has been replaced, as you can see in this picture here, I have all the red arrows going to. These are your screws that connect the board to your heatsink. These screws are crucial to get in all the way and make sure they're properly seated. As you can see, these are barely in, so of course it's not going to be able to dissipate that heat from the board to the heatsink. That's what the heatsink is for, is to remove the heat and protect that board. Also, the pictures to the right are showing you where the thermal paste would go. Again, time you replace that board, it's going to come with a little package of little tube of thermal paste. So you'd want to use that thermal paste, apply it to the parts that are circled there on the board, and be sure to get those screws in tight. You want to be sure to get all the screws in. If you're missing the screws, we can give you the dimensions on those screws. The screws are 3 millimeters, 5/8 long with a 1/4 inch washer. But again, just don't lose them and be sure to get them all in. I'm going to replacing that board. So if everything checks out and you still get an H5 and the compressor does not run, then we need to check amp drawn on all 3 legs. A compressor should attempt to start 3 times before generating H5. So it works perfectly as we need to amp all 3 legs of the compressor. So the compressor will try to start at the 30-second mark of the condenser fan coming on. So what I tell people is to get your amp clamp on one of the compressor wires. And after a hard reset, turn on power. The condenser fan comes on right at 30 seconds. We're going to be watching for an amp draw on the leg you have it on. If we have amp draw on all 3 legs, then the compressor is stuck and needs to be replaced. Amp draw can range. Again, there's no locked rotor amps on inverter-driven compressors. So we're looking for some kind of amp draw. Now, if we don't have amp draw on all 3 legs, then we have a bad board and need to replace that board. If the compressor does run and amperage keeps increasing, then we need to go back and verify the basics. Proper charge and vacuum, the paste and screws are done properly. Make sure they have adequate airflow. Does it have dirty coils or filter? Is the unit cross-piped or wired? Is the unit over or undercharged? Do we have a restriction? Or is one of the thermistors or sensors out of range? If the basics all check out and we have a loud compressor, then it may be internally damaged. Here are some things to consider. If you're in cold climates and the compressor warm-up was not performed, that would definitely lead to some damage to your compressor. This is very important as it allows the compressor to warm up the oil in the compressor, so when it starts, it probably lubricates the moving parts of the compressor. If it was not, again, it can permanently damage your compressor. The picture to the right shows proper warm-up time, kind of gives you different parameters. So if it's above 50, you'd at least want to have that. Now we're going by the coldest temperature in the last 24 hours, so something to consider. So again, coldest temperature in the last 24 hours, say if it's 50 degrees or above, we need 1 hour of compressor warm-up. 32 degrees to 50, we'd want a 2-hour warm-up. 14 to 32, we want a 4-hour warm-up. And below 14 degrees, we want an 8-hour warm-up. So what I always tell contractors to do is when you get there to do the install, first thing you want to do is just hook up main power to the unit. So that way we start warming that compressor. And then just do the rest of your install, like piping, wiring, and everything else. Your brazing, vacuum. And that way, by the time you're done with the install, it's just about ready to go. Otherwise, if loud, the system may not have been properly evacuated, ran overcharged, or low refrigerant, which can severely damage the compressor as well. So if everything checks out, we went through the list and that compressor is still loud and we didn't do a cold start on it, it may be something, as simple as the unit ran overcharged, undercharged, or the dirty condenser for a long period of time. And and cause damage to that compressor. So don't forget about our air code tool again, found at greecomfort.com. Under the contractor dropdown, this example here, I used H5 and punched in H5, and of course it came up with the step-by-steps that we went by, but again, I added some more to it. What there's the step-by-step of what to do. So thank you guys, and again, with Gree, we're by your side.
All right, we are back. Hope you enjoyed that video on the H5 that JD did. So, JD, I think we should jump right into questions. What do you think?
Yeah, I think so. Like
All
we
right,
got
so
two so far.
Yeah, the first question that came up was, what do you think about smart lock flare fittings? Have you seen leaks? You want me to answer? Or you want to answer it?
I can handle it. So of course we don't test third-party connections. We have not had any experience with those. If you choose to use them, you can, but if they do leak, you're going to be the one going there and making the repairs. Like I say, we don't test third party, and we haven't had any experience yet with those, but if you choose to use them, you can.
Well, my opinion on that, because I'm a cheapskate, right? If you buy a good flaring block and good flaring tool and a good flaring gauge, you can save yourself a whole lot of money just making flares and not having to buy fittings. So you still should have a torque wrench, because even though that's a third-party connector, you still got a flare connection. You still got to torque it to the unit for the flare. So
Good point.
But if I guess the other way to look at it too is, if I do one flare it properly, use a flare gauge, I've got 1 point of failure. Okay. If I use a smart lock fitting, I've got 2 points of failure. I got the flare still, and I have the smart lock. So now I've created an extra joint, right? So you got the where the pipe goes into the smart lock fitting, you got that joint, and then you also have the flare connection to the machine, the second joint. So I would minimize my losses and just do flares. That's my opinion. Everybody has their own opinion. It takes too long to do flares, whatever the reason may be, and much rather use third-party connections. And if they have great luck with them, that's fine. So as JD said, if you have a leak in that machine, that flare connection that you're doing is your own warranty. It's not warranted by the equipment, right? So I guess what I'm saying is, what works best for you?
Right.
Yeah, we don't test them. So nor do we sell them. So some of our distribution that we sell to may sell them, and they may recommend them, and that's fine. But we don't sell them or test them. So all right, let's move on to the next question. If the screws in the board are really important to get back in for the heat sink, why don't manufacturers send new screws? That's actually a great question. And I don't know the answer. Do you, JD?
No, I don't know the answer either. I know we do have the specs on those screws, and like you say, you can find them at most hardware stores, Home Depot, Lowe's, your local hardware store. So it's not like they're some oddball screw size that you can't get at your local store either.
Yeah, but I tend to agree with them.
I know, I do. I
am going to reach out to the engineering side of Gree and the parts side, or however it works, right? And see if they can't in the future start including the screws for the inverter driver with the replacement boards. Give you a little baggie of those screws. So it's a great question. And they don't supply them. So we know that already. And I don't know why. Probably because they've never been asked to. So, but I appreciate the question and I appreciate the input, and we will make the suggestion. I can't promise you they'll do it, but more than likely they probably will. So, I mean, because you're talking what, 5, 6 screws or whatever it is per board. They
Yeah.
throw them in a little baggie and throw them in with the parts. Yeah, I think they'll probably do it. So we'll see.
Oh yeah.
But yeah, I've already wrote it down. I'm going to see if we can't move forward and get that implemented.
Oh yeah.
So, all right, JD, is there any other questions rolled in?
Let's see here. One more question that came in. How do you feel about flare protection or some type of seal, such as Nylog? So our thoughts on that, if you do the flare properly, you should not need any seal. Again, that's the whole purpose of a flare connection. The flare does make the seal. So, I mean, if you're using Nylog, you get the chance of getting some of that Nylog into the system, depending on how much you put on there. And then that
And
can
we've
then,
actually had systems that were replaced for whatever reason sent back to us and had Nylog in the pipe.
or
That's
in the
what was causing.
strainer, it'll make
That's
its
what
way
was
back to the
causing.
strainer.
Yeah,
Yeah.
that's what's causing the flow problem. So I agree with JD. As long as you're doing the flares properly, using a flare gauge, using a torque wrench, torquing specifications, you guys shouldn't be having leak problems. And you shouldn't need third-party accessories to keep you from having leaks.
Yep.
That's my stance on it too.
And a
So,
torque wrench to get that tightened down, because I mean, like typically doesn't leak at the threads anyways. It's actually at the flare that's going to leak out where the pipe goes through the connection.
right. The flare is what makes the seal, not the threads.
Yeah. Yeah.
And if it's torqued properly, I mean, I can't see that. I don't see the fitting loosening itself up
No.
just from the normal threads without any kind of Loctite or anything like that. But again, if you guys feel it's necessary that you got to do that to keep your installs from leaking, I mean, you do what you got to do. But like JD said, you need to be really careful with that stuff to make sure you're not getting it internal to the flow of the refrigerant and the compressor oil.
Right. Oh yeah. Looks like we had a couple more come in.
Cool.
Let's see here. Another person just wanted to say, I thank you guys as a tech. It's refreshing that I can get adequate information I need. Ever since I started watching, I've grown confidence in the mini split system or multi-pro systems. So it's good.
I appreciate that compliment because, it is a new world. In other words, new to a lot of guys, right? Everybody's used to the typical heat pump, air conditioner, bang on, bang off unit that's got a contactor and a capacitor and stuff like that. When you're talking mini splits and you're throwing an inverter board in there and a filter board and all these thermistors and EVs, and it can be a little overwhelming. So, that's part of the reason why we do all these trainings is to help lighten that load and not only teach you how to fix a GREE unit, but understanding how the systems work as an inverter driver, how the thermistors play a role, and so on and so forth. So it's great knowledge that you can move. I can't share. One manufacturer to another, air codes and stuff like that don't always share, but the basic principle of operation from one mini split to another is the same. So if you get confident and get good at fixing GREE units, inverter driven units and stuff, you should feel more comfortable about walking up to any brand of a mini split and be able to confidently work on those machines. Now you may have to get more specific data for that machine from that manufacturer and what their air codes mean and stuff like that. But we really try hard. JD, you can attest to this, that we not only train on our product, but we train on the principles and operation of the equipment to help you guys understand how the stuff works so that it makes you become a better technician.
Absolutely.
So, and that's the part of the job that I enjoy doing.
Oh yeah.
I want guys to be able to, feel more confident working on these machines.
Absolutely.
So
Looks like we have another question here from Bob. Let's see. On a 3-head system with a multi-unit outside, if you have to remove one head, how do you pump down the one head, or do you have to do the whole system? So that's a great question, Bob. Yes, you can pump down one head or one zone. The way you'd want to do that is, so say it's zone A, you're trying to pump down, you will have to close down the valves just on B and C if it's a 3-zone head, and then turn the system on, and of course close your liquid line off if you're in cooling mode, and then watch your suction side. It'll pump down, and then close your suction valve off, and you're pumping down that one head. But you will have to close down the other zones, just because it's a shared manifold, and that refrigerant will continue to flow through the other zones. Did I explain that properly, Greg?
Yeah, I couldn't have said it better myself. The only thing I would tell you is, just to be a little more clear, before you do anything, you're going to close the valves on the heads you don't want to mess with, both liquid and gas. You got 2 pipes for each one. You need to close the valves for each circuit. Like so, circuit D, you're not messing with that one. Close the gas and liquid pipe. Circuit C, you're not messing that one. Close both the gas and liquid service valves. B, you're not messing with that one. Close the gas and liquid service valves. Now the only service valves you have open are for A, which is the problem unit, for let's say in this example. Then you would start up the machine, close that liquid pipe. You still should be reading your suction pressure. It'll pump down. You get down around 0, close the gas pipe, pull the disconnect, shut her down. Now you're ready to do whatever you got to do with that particular head.
Yep.
That's perfect.
Good deal.
And there's some of them, they got this refrigerant recovery mode and all that. You don't need to do all that.
No.
Just put it in cool mode and do your pump down. It's not that big a deal. And you should, even if you have a multi-zone system like that, and let's say you've got pretty long line sets and stuff, and you've had to add additional charge because you exceeded, I guess, it depends on the unit, but let's say it was 131 feet of total pipe you got charged for. And let's say you got 200 feet of pipe, and you had to add charge for that when you initially installed. Okay. But now you're wanting to pump that back into the outdoor unit. Well, if you're only messing with that one head and you've closed D, C, and B, you're storing a lot of that refrigerant in those extra heads already. So you should have no problems pumping down that A circuit back into the outdoor unit, because you're not going to have all of the refrigerant in the whole system in the outdoor unit, because you still have charge in D, C, and B.
Right.
Makes sense, right?
Mm-hmm.
So that's the one thing I do like about the multi-zone units, is that you can isolate each head. So, and JD, I don't know if you talked about an E6. If you got an E6 on one multi-zone unit, I've told guys before, just to see, take the functioning head that's not giving me E6, hook it to the circuit that I am getting an E6, and see if I still get an E6.
Right. I did not say that, but yeah.
You're not changing piping or anything like that. You're not going to leave it running long enough for that to be the issue. But let's say the A circuit's the only one, that particular indoor head's the only one giving me an E6 error code. Power it down, disconnect your wiring for A, take the wiring from B, move it to A, power it back up, and still see if you get E6. If you no longer get E6, then your problem is in that wire or that A circuit head.
Right.
There's multiple different ways you guys can go about troubleshooting these units. So, all right. Any more questions, JD?
No more questions, but just a comment from Steven. He did say, quality of the copper might affect your flare, so that is a good point. Be sure to know where you're getting your copper from and get some good quality copper. Some of it can split, if it's not quality copper, can split when you're trying to do your flares and flaring that pipe. So yeah, there's a good point to keep in mind of the copper.
And that's the other reason why a visual inspection, making sure after you flared it, it didn't split. You don't have any, problems with the flare itself. So
right.
Yeah, you got to get your eyeballs on it, take a good look at it. Like
Oh,
me,
yeah.
least put on reading glasses because I don't even think I'd be able to see it anymore. All right.
Oh yeah.
Any other questions coming?
It looks like all the questions. Let me refresh real quick. No questions.
All right. So I do want to give a shout out to what we got coming up next, which is going to be toward the end of October, October 29th and 30th from 11 o'clock Eastern to 1 o'clock Eastern. We will be broadcasting on the MultiPro Systems, the new R32. Live from Atlanta. So it's a little different than what we do with the Tech 90s. Tech 90s, we play pre-recorded video and then we come back and do Q&A. When we do it from Atlanta, it's all live. So if I say it all wrong, you're going to hear it all wrong. So, and I reserve the right to make mistakes, just like you guys do in the field. Don't tell me you don't make mistakes, because if you ain't making mistakes, that's because you ain't working. You're sitting at home on your sofa watching TV.
Oh, shots fired.
You're never going to make mistakes is to never work, because nobody's perfect, including myself.
That's
JD's
right.
getting closer and closer every day, but he still ain't quite made the mark. So, but anyway, October 29th and 30th, we will do the startup of that new R32, kind of go through the commissioning of that unit. And then the next day we will go into more about the controllers and pressure settings, A2L alarm reset, things like that. It's all brand new equipment because MultiPro is just now switching over to R32. I plan on also, I didn't in the last broadcast, I didn't have a ducted unit down there yet. So that'll be in one of those 2 days as well. I'll have a ducted unit there. We'll kind of peel it apart, kind of do a show and tell with that. So I think that's going to be a great show. I also did order up a heater kit to put in one of those air handlers down in Atlanta. So we'll kind of go over that heater kit and the installation of that and stuff like that. So a lot of good things to come in the next broadcast. So I really encourage people to join. Like I said, that's going to be live. And typically the live trainings, we don't always repost those on YouTube. We basically down the road, we probably will, but we would typically, rebroadcast in like a Tech 90, and those are the ones that we throw up on our website and actually put them out on YouTube. So anyway, so I encourage guys to join us live. So be right before Halloween, so it should be fun.
That's right.
All right, so before we get out of here, JD, you want to refresh one more time, see if we got any more questions?
Sure. I'm doing it right now.
Questions, comments, whatever you guys find. If you guys
Nope.
think we can do something better, you got a suggestion for us to do in the future, please share, because, we try to put these together the best we can, but, some people come up with other great ideas, like the suggestion of including the screws for the inverter board with the replacement boards. I think that is a great idea.
I do too. Yep.
But in the meantime, go to your local Harbor Freight or Lowe's or Home Depot or Parts House, or wherever you want to go. And I highly encourage you, buy yourself a magnetic tray. And as you're taking those screws out, you put them right in that magnetic tray instead of dropping them down in the machine and have to go digging for it. And you go digging down the machine, you find out there's a rattlesnake in there, and now you don't want to get the screw. So you laugh about that, because I actually had that call one time where a guy dropped a nut down inside the unit, and I was on the phone live with him, and he reached his hand down and there was a snake. Now, I don't know if it was a rattlesnake or not. I asked him which one it was, and he says, I don't know. I didn't stick around long enough to find out. And I said, well, that's probably a wise decision.
Oh, yeah.
So, but he didn't hear any rattles either. So, anyway. Yeah. So I highly encourage, don't lose those screws.
That's right. Yeah, no more questions came in, so.
All right, guys. Well, we'll leave the Q&A open for about another 5 minutes or whatever. Again, if you guys got suggestions, please give us your suggestions, comments, good, bad, and ugly. JD can take it. I'm going to blame it all on him anyway. With that,
I'm used to it.
We'll see you guys next time. And remember, agree,
we're by your side.